Today I'm going to show you how to export your structural results from Karamba3D using the report component. Report outputs tables that are generated by collecting various results computed during the model analysis. The typical output is an Excel file, and the results are organized thematically into tables and worksheets. Before I dive into how to use the component itself, let's just quickly go through the inputs and outputs. The model input takes the calculated Karamba3D model from which the results will be extracted. Here, in File Path, you can specify the destination where the report will be saved. By default, the report is written as an Excel file and it's saved in the same directory as your Grasshopper script. You can also set the file path directly from the report component context menu by just right-clicking, select File Path, and then choose the folder that you want. If you zoom into the component, you can also see the current file path displayed directly on it. With the selection input, you can choose which data you wanted to be included in the report. This input follows a specific syntax, which is similar to the structure commonly used in terminal tools. The right input requires a button or toggle to trigger the report generation. Once I activate it, the component processes the selected data and writes a report to the specified file path. In the outputs, info provides details of any errors or issues, and success shows you whether or not the report was created. Now let's take a look at the syntax used to generate reports. To start, let's write help into a panel. The syntax can be broken down into a command followed by options and arguments. With help, I can also see which commands are available and what kind of data I can export. This is very useful when you're not sure what's available or how to structure your export. In the info output, you can see the available commands and options such as beam displacement, collects all the beam displacements, beam forces, collecting the beam forces, model info, reaction forces that collect reaction forces at the supports, help, and version. For this tutorial, I'm going to use beam forces and reaction forces as an example. To learn more about this or any other specific commands, it's very helpful to write the command name followed by help. This will give you detailed information about the command structure, including all the accepted options and arguments. In the output, you can see that for beam forces, it's possible to specify the element IDs, load cases, position, and also a name to identify the generated data. You'll also notice that there are two different ways to write the command. This is because there are two formats that you can use when querying these commands: a short format with a single dash and a long format with a double dash. Both these formats are equivalent and they can be used interchangeably. For example, if I want to query the element IDs, I can either write -I or double-ID. The same applies for the other options. For example, load cases can be written as -L or double-load case, position as -P or double-position, and name as -N or double-name. You can also export multiple options together by writing them sequentially and separating them with a comma. Let's try this now. I'm going to export the beam forces using some of the available options. The first part of the syntax is always what you want to export. So in this case, I can start with beam forces. Next, I want to specify the beam IDs. These can be found in the create linear element component. Here, I'm using the main beams, so let's write -I main beam. I will then specify a position using P. By default, this is set to 0, 0.5, and 1, but for this tutorial, I'll use a few additional values. Let's write -P, 0, 0.25, 0.5, 0.75, and 1. I will also specify a load case. There are several options available, but here I'll use -L, and then let's write ULS. Finally, I'll assign a name to the output using -N, and I will name it main beam forces. This will be the name of the Excel sheet. To export the report, I just have to switch the right toggle to true. The Excel file is then generated and then saved into the folder that I specified earlier. Exporting reaction forces follows a very similar procedure. Once again, we can use help to see which options are available. In this case, the structure is almost the same as for beam forces, but instead of element IDs, we need to specify node indices. You can preview the node indices directly in the model view by enabling them in annotations. In my case, the support nodes are 0, 2, 4, 6, and 8, and I'll use these as a part of the syntax. For this situation, I'll use the long format of the command. I'm going to start with react forces and then specify the indices using ~index 0, 2, 4, 6, 8. For the load case, I'll write ~load case, SLS, and finally, I'll assign the name reaction forces using ~name. Once I set the right toggle to true, the report is generated, and the reaction forces are exported. This is the result. You can see the different positions, load cases, forces, and more. Thanks for watching, and I'll see you at the next video.